Thank you for the introduction. My name is Agbona. I'm from IDSAI, International Institute of Tropical Agriculture. I'll be taking you through data management in multidisciplinary African RTB crop breeding programs. Thank you. So IDSAI Cassava Research Program is conducted in different hubs in Africa, from Western to Southern Africa. A quick background into our data management from the inception of the breeding program. In 1972, when the program started and it was all paper-based data collection system, we have transcribed the data into photograph compiled in PDF. That's for 20 years. Then after 17 years, 16 years later on the line, we adopted just pure Excel files. And then we started database usage in the program. So thereafter, we teamed with Biodiversity International to develop crop ontology under the Generation Challenges program. And then we understood the importance of crop cassava trait ontology. So thereafter, we implemented international crop information system. But we couldn't adapt it to our system because of genotypic data storage. Then in 2012, we started Next Gen Cassava project, which is to implement genomic selection in cassava and to create a fully open access cassava database called Cassava Base. So this led to breed-based family of crop databases. Since then, the cassava trait ontology has evolved, and as of date, we have 365 variables described. And thanks to the good work and collaboration with Elizabeth Hanold and the team, and the cassava trait ontology is pivotal in the use of a database system. The vision of the project is to empower farmers through innovative, sustainable cassava breeding. And the aim is to modernize partner cassava breeding institutions in Africa using cutting-edge tools for efficient delivery of improved varieties of cassava. The beneficiaries are cassava farmers in sub-Saharan Africa. We work in 13 institutions in 4 continents and 7 African countries through the Community of Practice Partnership. And within the project, we have 3 divisions: survey, research, and breeding. So Cassava Base started in 2012 and is built as an open access database with breeding management system functionalities to improve cassava breeding. It's an open vehicle for enabling better breeding demonstrated by increases of genetic gain, better adoption of varieties, and increased learning for all participants within the global cassava community. It is developed and hosted at Boyce Thompson Institute in the US, and the mirror site is hosted at IIT in Nigeria. As of February 2021, this is the statistics of the database, the number of users, breeding program, the germplasm, the genotype, and the phenotypic information we have in the database. And like I've said, trait ontology sits at the center of the database. It's highly pivotal to the use of the database. So these are the sister family of databases that are metamorphized into breed base. So we have yam base, rice base, sweet potato base, and diced potato base now, I think. So to using the database, it is important that we build the capacity across hubs and partner stations. And so we do regular training, and we also conduct virtual follow-up calls to ensure people use the database. And we have SOPs developed on the use of the tools in the database. And these are some of the pictures we've taken across the different stations. And we have been doing this for more than 8 to 9 years. So the need for breeders to breed varieties that will offer significant benefit to farmers and replace older varieties that still dominate the market, we have adopted the concept of product profile. Product profile is more of a breeder's product portfolio that guides the breeder on the kind of varieties to breed. And this is an example of the product profile in Nigeria. The different hubs have their product profile. So we have cassava for the industry, for fresh market, and for food product. And we have the biofortified cassava. So once we understand the product profile, so we can use the database to manage issues in the crop ontology. So we use the ontology to identify the target value, the benchmark variety, which variety do we want to replace. So as we breed year in, year out, we can use the database to tease out the clone under development that meets this criteria or surpass this criteria. So this is still pretty new in the database. So considering the different product profile that we have adopted the stage gate approach, which is from product design to release and deployment stage, and the breed base sit at the center of this. So for our product design, we consider market research and interactions with the food chain actor to design our product. And breed base is used in managing most of this stage gate, except for the social inclusion part. I will get to that later in my presentation. So integrating feedback from social data, we consider the end user context, such as household type, their farming system to agronomic practices, the complementary roles of as food chain actor, because they can have dual roles. And we also consider cassava as a multi-food product crop. What informed their preference of the food product? Is it based on the social segment they belong to, or is it a function of how locally important the food product is? And these are the tools we use for collecting social data through our survey division. Tricot approach, 1000 mind, we have the mother baby child approach and the G+2. These are some of the pictures we took, and some of the inferences we could make from this from social data is to understand gender preferences across different relevant social identities. So breed based. So from our early generation trial to late stage testing, we have adopted use of several software applications that runs on mobile phones and tablets. And the beauty of this application is that it is designed such that the data export from it can easily be migrated into database with minimal data validation. And this is through collaboration with a project called PhenoHub. So we use it for most of our field phenotyping from across all trial stages. So linking breed base to other repository, the crop ontology remains important in this regard, and this is one of the pictures we took during the discussion we have with Boyce Thompson Institute and Elizabeth Harnod and Marie Angelique. The picture was taken at Boyce Thompson Institute in the US in 2019. So there is also BRAPI, the breeding API. The breeding API, you can do a lot of BRAPI calls, which is more of posting and getting information into databases and repository through JSON objects. And one of the ways we have used BRAPI is we have adopted BRAPI in the complementary canal archive network, which is more of the internal repository at IDSAI, courtesy of a colleague working on this. And we have used BRAPI to integrate that into Cassava base. So more of our survey data, we store that on CCAN, and we can link that to the field trial conducted from such survey, which is hosted on Cassava base. So this is one of the examples. BRAPI has also been adopted in the breeding management system to link to Cassava base. Challenges of linking data. This is a technical aspect of it. License different use of a databases. Our database, we use Toronto Agreement, and a good example for some of the linkages like CCAN. CCAN uses CC by 3. This is one of a challenge. The difference in database schema limits connectivity. In our database, we use shadow schema. A different database that wants to link might have a different schema. We have varying data type from phenotyping to like a near infrared spectroscopy. These data have not been annotated to plot level, so it's easier. It's difficult linking this within the database, and also phenotyping data from ground penetrating radar, which involve using radio wave to estimate root biomass of root and tuber crop under the soil. Inadequate lack of metadata limit the use of data sets. Some historical data set does not have enough metadata, so it limits the use when you link such data. To the management side, scientists and institutional willingness to share data, this is a big challenge. The receptiveness of a user to adopt a new platform. Then the experience of data curator. We've seen this a lot, when you have duplicated assertion, trials are uploaded into the database, it gets a study ID, then there is a problem with it, it's deleted, then a database or repository has been linked to that, and the ID has changed when you re-upload the data. These are big challenges. Sufficient training to enhance the adoption of database management system. The funding for sustaining databases is highly important. To the social side, following the ethical guidelines and protecting privacy for survey data, interpretation of qualitative data to enable use by breeder. The quantification by breeder is completely different from the qualitative assessment by the farmer, because the farmers, the processor, they tell you in verbatim what they do, and it's completely different from the quantification. There might have been tools developed in this regard, but how have they been integrated into databases? Implication for breeding, tracking genetic gain, especially genetic gain in farmers' field. Then we could use the database to estimate realized genetic gain using historical data. This is one of the things, but you can have a change in your breeding settings in order to accommodate this varying consumer preferences and quality trait. Funding is also important when you look at the number of varieties you want to breed to meet consumer requirements, considering the different product profiles. Looking forward, in terms of breed-based improvement, we would like to integrate variety and social economic variables and probably explore the socioeconomic ontology developed last year by Elizabeth Arnold and some other colleagues. And we would like to look more deeply into the quantification of post-harvest data. We realize that from planting to harvesting, G by E influenced that, but at the post-harvest data part, we need to look at combined interaction between the processing, the culinary, and the social aspect. A good example, when you try to look at farmers prefer varieties that dewater easily. When they're processing, they want those that lose water easily. But when you look at this, it's seasonal. During dry season is different from wet season. So you need to factor all this, and it's easily done when you have all this happening within the database. Then probably ontologies in local languages. Thank you for listening.
Thank you very much, Fola. That was a fantastic overview.